Hello friends, this is Matt Domain, and today, as you see, my board is graphical, so I will discuss graph, and as the title suggests, is sine function. So I basically discuss how and when a sine function is bijective. The question is sine function is is sine function, I usually write the question whether there is the reason. So is sine function bijective? So the answer to this question is clear no. Okay, the sine function is not bijective, but we find sine inverse. We basically find sine inverse in inverse trigonometric function. We find sine inverse. So if sine is not bijective, then how can we find sine inverse? Whether sine inverse is something different from sine function or what? Now for that you should know what is a sine function. Okay, what is a sine function? What is a sine function? What is a sine function? So function f is simple function that we all read in our HS levels. From R to R, defined by f of x is equal to sine x. This is a sine function. This function is not at all bijective. So we used to find some map which is bijective using sine, and then we can say what is the sine inverse. Okay, so let's see what is this sine x. If you plot sine, it looks like this wave. Okay, so I have not marked anything, so this is pi by 2, this is this is pi, this is 3 pi by 2, this is twice pi. Similarly, this is minus pi by 2, this is minus pi, minus 3 pi by 2. So this is a function. Now this function is not at all bijective. Why? Suppose this is your half. Okay, so this is half. If you draw a straight line, then you can see at this point it cuts the curve. Okay, these are the points. Means at x equal to this one, this one, this one, this one, and infinitely many such kind of things will occur. At these points, the value of the sine curve, the sine of x at all these points is equal to half. So the function sine is not bijective. Okay, because this is not 1 for different, say x1 and x2, x1 and x2 will get the same value of f of x1 and f of x2. So it's not 1 so question of bijectiveness does not arise. Now we can make that function bijective. How? Let me magnify this portion. What I have did, I have taken, this is minus pi by 2, so I have taken, mainly I have taken this portion, okay, in bold graph, and this portion of graph is used. This is the x portion. Okay, this is the portion we have taken complete from here to here. and this is the portion we will use. So it's in bold line and rest of the curves in dotted line. Okay, fine. So now you see you have from this part to this part, your domain is minus pi by 2 to pi by 2. If you pick any point from 0 to pi by 2, suppose any x, then the corresponding sine x is on 0 to 1, on y-axis of 0 to 1. So this is the point. Similarly, you pick any point from here, the corresponding value will get from this. Now if you take from one point from 0 to pi by 2 and one point from minus pi by 2 to 0, obviously their images are different, their points are different. Okay, now if I take 2 points from the same side, then also you can see however close you can pick the point, however close you can pick the point, the resulting image is always going to be different. Okay, same thing in this part also. It means for each point in the domain there is exactly one point in the codomain, or you can say not codomain actually. In that case you have to restrict that part also, but now I am concentrated on oneness. So there is exactly one point in the domain which is different from rest of the points. Means if any two means distinct point on in the domain have distinct images in the codomain. Now this function is by 1 1. So which function is 1 1? We have defined R to R. This is not bijective. So what we have defined now, we restrict the interval from minus pi to pi, comma pi. Okay, now what is this? This function is 1 1. Now again if we restrict this portion from minus pi by 2 to pi by 2 to minus 1 comma 1, then this is 1 1 1 2, or you can say 1 2. 1 2 is not, it's 1 1 and 1 2. Now it means the function, this particular function is bijective. Definition is same. See, definition is same. Definition is sin x only, but if you restrict the domain from minus pi to pi and codomain, better to use something else. Codomain from here 1 to minus 1, then the resulting function is bijective. So this sine function is bijective, not this sine function. Remember, function, the two functions are same if their domain is same, codomain is same, and the function definition gives the same value. Here function definitions may give the same value, but the functions are not same because the domain, I have changed the domain and the codomain. So the result in this sine function is bijective. Now for this sine function I can define inverse. Now is already 9 minutes, so I am not going to go that far, but similarly you can get that sine inverse curve. It is in the textbook, sine inverse, the curve of sine inverse of x, okay, from 1 to minus 1, and then you superimpose this on this curve. You draw first sine curve, then you draw the curve of sine inverse. Okay, you will see the result, that what happens when you superimpose these two curves. These two will form like this type of thing, like one will form like this and other may form like this, Okay, so this is symmetrically you can find a symmetry between them. So this is how we show sine is bijective, and therefore sine inverse could exist. The definition of sine inverse come from that one. You cannot say sine is means you cannot say that sine inverse exists and then GOF FOG, because you don't know the definition of sine inverse of x. Okay, so this is how it works. Okay, thank you, goodbye.